So good morning, everyone, and welcome again to this new training within this series of training that we are doing for the European Weather Cloud. So I'm Roberto Cuccu, working the user services at ECMWF. I'm together with Uroosa Farooq from EUMETSAT. And we are here today to talk about an introduction to the Openstack API and the access and usage of it within the European Weather Cloud. So let's get started. So this is the outline of this webinar. So we'll proceed with an introduction about these new features that we just recently opened and also the motivation for that. And then we'll go through how to request access to this feature, and we provide some information how to get started. And finally, we will have a brief demo on simple demo on how to create a new server using OpenStack command line client that exploits the OpenStack APIs. So this time, instead, let's say, of repeating again the basic information about what it is the European Weather Cloud and also which are the entitled user to request access to the EWC and also the related information, I would like to point you to the previously held webinars that are published now also on our knowledge base documentation. You can find there all the information that you will need if you are not yet a user and you like to request access. You will find there the introductory webinar that we held at the beginning, and then also the various thematic ones that includes how to work with the EUMETSAT data access services within EWC, how to work with Jupyter Lab and with the ECMWF datasets, and also how to create a customized instance type and work with the S3 object storage. And finally, also the last one that was about the tenancy administration. So please consult all this webinar. You'll find all the information that we provided before. And let's focus more on the subject of today's presentation. I will start with this slide that you may have seen already in some previous webinar that summarizes the high-level design of the European Weather Cloud that has a user space that contains several items like main website, knowledge-based documentation, support portal, the Rocket Chat discussion platform, and also the accounting platform. And then another layer, which is the cloud orchestrator that relies on a cloud management software that is called Morpheus. That is, so far, has been, let's say, the primary access for the users to work with the resources on the European Weather Cloud. So from Morpheus, indeed, it is possible to deploy, control resources on the interconnected cloud infrastructure. And we had an instance of Morpheus at ECMWF and one at EUMETSAT. From both of them, it's possible to work with the resources on the interconnected cloud infrastructure, and also in this case are present at ECMWF and also at EUMETSAT. And both of them relies on OpenStack and Ceph technologies. So at the moment, that was the primary access, and the users didn't have access to the underlying OpenStack infrastructure. However, we just recently opened the access also directly to the OpenStack infrastructure via APIs. So the Morpheus remains the primary access for the web graphic interface, while now there is also the possibility to interact with OpenStack directly via the APIs and OpenStack Application Credentials that we are going to show in this webinar. So the motivation for that, there were various reasons. Primarily, we received several requests from users to have this kind of access, and the reason for that was mainly to support the automations of deployment and the provisioning of the infrastructure directly to OpenStack, and leveraging also on tools that, let's say, implement the paradigm of infrastructure as code, as the well-known Terraform tool, for instance. And also, beside of, let's say, this, the support for the usage of these tools, there was also the reason to improve synergies and harmonization on other OpenStack-based infrastructure. We can say indeed that beside the major commercial cloud provider like AWS, Azure, or Google Cloud Platform, most all the other cloud implementation mostly relies and are implemented via OpenStack. So it's a very well deployed and known infrastructure platform, and is supported indeed for this reason by many tools and providers. So, for instance, there is the OpenStack command line client that will be demonstrated within this webinar, but there is also a Python SDKs. There is the mentioned Terraform and equivalent OpenTofu. There are modules for Ansibles, and many more tools to support, let's say, the APIs of OpenStack as well. So for this reason, we decided also to open this kind of access for the users of the European Weather Cloud. So let's just briefly mention what it is OpenStack, and summarize for who doesn't know it yet. So OpenStack is basically an open source cloud software that is meant to control and manage compute and storage and networking resources of the underlying hardware infrastructure, and to provide these infrastructure as a service capabilities. So this is an advantage for either for the administrator that helps to work effectively and also in a flexible way with the underlying hardware infrastructure, but mostly for the users that can work with these kind of resources in a flexible way. All the management and also of, let's say, the provisioning of these capabilities performed via APIs, either externally to the final user, but also the internal OpenStack components are able to talk between themselves via well-defined APIs as well. So the OpenStack platform is able technically to manage various type of resources like bare metal, virtual machines, but also containers. However, most of the OpenStack implementation, and also especially the one that we are adopting at the European Weather Cloud, mostly focus on the management of virtual machines. We also can mention that OpenStack is not a unique big project, but is composed by several loosely coupled services that follows a different project's development, and they are, let's say, coordinated all together to perform an OpenStack release. You can see indeed in this map is summarized, let's say, all the available services and projects within OpenStack. You can find it also on the OpenStack documentation. And you can see that on the core, on the central part, there is the core of the services that includes indeed the one meant to manage the compute, storage, and networking resources, but also some workload and orchestration tools. But beside of the core, there are also client tools like the OpenStack client that we are going to use in this webinar, the Python SDK, and then there are also integration tools and operation tools as well. And also for the administrator, for the deployer of the OpenStack, there are a set of projects and tools for the deployment and the management of the OpenStack platform itself. So this is all the a map showing all the tools that are available. However, it's not mandatory to deploy all these services in a certain OpenStack implementations. Indeed, let's say it's possible to build and open and deploy OpenStack just with a selection of these services. So you can think it about like if it was a sort of Lego blocks that where the deployers can compose and configure the services to serve the purpose and the use cases that they need to serve, and also optimize the configuration for the underlying hardware infrastructure. So also in the context of the European Weather Cloud, not all of these services, neither at ECMWF, neither at EUMETSAT, have been deployed. However, there is a set of core services that are commonly deployed in almost every OpenStack implementation, which are summarized in these slides. We have, this is also useful to know in case you need to browse documentation and you can, let's say, know which service provides what. So the Keystone service is the identity service and provides a service catalog. Indeed, as I said, not all services might be deployed, and Keystone is the one that keep track of which services are deployed in that OpenStack implementation, and also together with the endpoint references. But the main purpose of the Keystone service is to provide the authentication and authorization layer. So there is Nova, that is the compute service, which the one that is responsible to manage, let's say, the compute instances, so the virtual machines. Neutron is the networking service that, let's say, provides and manages the networks, routers, security groups. Glance is the image service, since to deploy a virtual machine typically is based on a certain source image, and Glance is the service that manages these images and also the snapshots of the virtual machines. And finally, Cinder is the block storage service, which is the one in charge to manage the attached disk and volumes to the compute instances. So in the European Weather Cloud knowledge base, we publish, and under the OpenStack API documentation, we published these 2 pages that summarize the services that have been deployed for each of the cloud infrastructure at ECMWF and at EUMETSAT. And also you can find the links of the related documentation specifically to the version of OpenStack that has been implemented. This is particularly important when you need to browse documentation to stick to the correct deployed version of that particular version of OpenStack, since from version to version of OpenStack there might be slight differences, new features, or slightly different behavior. So just keeping that in mind to just consult the exact documentation specifically for the infrastructure and services that you are working on. So with this, I pass the word to Uroosa, that provides some information about how to get access and get started with this new feature.
Yeah, thank you, Roberto. So good morning, everyone. Thank you so much for joining today's webinar. So my name is Uroosa Farooq, and it's a pleasure to be here with you all. I have a little bit of dry throat, so please excuse me for that. So now that we have covered, as Roberto said, the current OpenStack versions and services, let's see about how you can access the OpenStack API to automate processes and integrate with the infrastructure as code solution. So basically, you can find the full documentation on how to request the API access and get started with automation through the link shown in the slide, which will direct you to relevant page in the Confluence page. So this is like an excellent resource if you're looking to dive deeper into the OpenStack automation capabilities. So moving on to the next slide. So let's talk about how you can request the OpenStack application credentials. So basically, these credentials are the key when you want to authenticate your applications to OpenStack's identity service. So without needing to expose or embed any user passwords, and you can directly into your app's configuration. So instead of using the personal password, your application will use an application credential ID and a secret string, which is more secure and allows for safer and automated access. So this is especially useful for automation and infrastructure as code implementation. So how do you request this credential? So it's basically a simple process. All you have to do is raise a ticket in the EWC support portal. So the link is mentioned in the slide as well. So basically the ticket, we would recommend you to, the ticket should contain the ticket title. So the title should be the OpenStack app credential request, and include this in the ticket description. So your tenancy name, So whatever you have the name of your tenancy, please mention that. And then the scope and description of the use for the credentials, and the owner in case if if the person is different from the person making the request, and if there are any other relevant resources, notes, so please mention it in the ticket. Also, for your information, if the tenancy administrator is not the one submit the request, make sure to include them as the participant on the ticket. So once your request is processed, you will basically receive the two files. One is openrc.sh file, and other one is cloud.yaml file. So in the next slide, we will see more about these files. So the OpenRC file, basically this is used to export the environmental variables which are necessary for interacting with the OpenStack. And the clouds.yaml file, this file can be installed under this location. So .config openstack clouds.yaml on your machine. So basically both these files serve the same purpose. So you can either use any one depending on your preference. And these credentials will allow you to integrate your application securely with OpenStack. So moving on to the next slide. So this is how the OpenRC file and clouds.yaml file looks like. So basically, for the OpenRC file, you will get the details, and the credentials are saved in your IAM account. But here you can basically source it to export the required environment variables from the OpenRC file. So the command is shown right under it. And for the clouds YAML, you can just install it under this .config openstack .clouds .yaml path. And moving on to the OpenStack command line client. So basically, this tool is a way to interact with OpenStack services directly from your terminal. It combines the command sets for multiple OpenStack services like compute, identity, image, object storage, and block storage, all into an one unified shell interface. So it simplifies the process, letting you perform a wide range of tasks without needing to navigate through multiple and separate tools or dashboards. So if you are looking to install the OpenStack command line tool, there are a couple of options depending on your environmental setup. So one is Python virtual environment. So basically you can set it up in a virtual environment to keep the things isolated. And another one is Conda environment. So if you are using Conda, that's another option for setting things up. So once you have this environmental setup, you can install the client basically using pip, simply by running the command pip install Python OpenStack client. So once the client is installed, you can invoke it directly from your terminal by running OpenStack help command. So basically this will bring up the list of available commands. So you can get started with whatever service you need to interact with. It's a great tool for anyone comfortable working from their command line and wanting to automate or streamline their OpenStack management. So to create this Python virtual environment or Conda environment for keeping your OpenStack setup isolated, so ensuring that everything stays clean and manageable. First, if you're using the Python virtual environment, this is how you can create and activate it. So to create this, you can basically use the command Python 3 minus m virtual environment and then OpenStack minus environment, or you can give whatever name you like. And then you can activate this environment by just sourcing it to the OpenStack minus environment /bin /activated. So once that is done, you will all be set to install the OpenStack client within this isolated environment. In case if you prefer using or working with Conda, you can also create and activate it by just running this command to create the Conda environment, give the name of your environment, and then activate it. So in both the cases, once your environment is activated, you can proceed with installing the Openstack client as discussed earlier. So using either of this method, it's like a great way to keep your OpenStack setup organized and avoid any conflicts with other Python dependencies. So moving on, we will talk about how to get help when using the OpenStack client. So basically, this command line client has this built-in help system that is extremely useful, especially if you are just starting out or need to quickly check the available commands. So to get a list of global options and the supported commands, simply run the following command in your terminal. So as you can see from this screenshot, OpenStack help, and this command will basically display an overview of available commands along with the options you can use to customize and refine your request. So it's a great way to get a quick refresher on the available functionality, and it can also help you to navigate the OpenStack client more efficiently. So as you can see from this screenshot, running OpenStack minus minus help provides you with the structured list of commands, helping you get started and find exactly what you need in the matter of seconds. So in the next slide, here we have shown you how to get help for the specific command within the OpenStack client. So while the general OpenStack help command is great for getting an overview, sometimes you need more detailed information on a specific command. For example, here we have taken a server create, OpenStack help server create. So if you want to learn more about it, you can use this command to get help specifically to create operation. So OpenStack help server create. So this will display all the detailed information on how to use the server create command, including all the options, parameters, and flags you can use to customize the server creation process. So as shown in the attached screenshot, it provides structured help output that guides through the syntax, as well as giving descriptions for each available option. So this is a great way to quickly reference the specific command details you need when you are working in OpenStack. So moving on, in the next slide, we will discuss how you can extend the functionality of OpenStack command lines using plugins. So basically, OpenStack offers a number of additional plugin clients for specific services, and you easily install them via pip. So these plugins are typically named using the format Python OpenStack project client. So for example, if you want to add support for the Octavia load balancing service, so you would install the Octavia client using the command pip install Python Octavia client. Once installed, these plugins can make additional commands available for the main OpenStack client. So for instance, here, if you have installed the Octavia client plugin, you can use the following command to get the help for load balancer operations. So OpenStack help load balancer, and to add to the list to list the available load balancer, you can run OpenStack load balancer list. So basically, this is a great way to customize your OpenStack client by adding support for specific services as needed without cluttering your environment. So now moving on. So let's go over how to get started with the OpenStack command line client by configuring your shell environment. So basically, the first step is setting up an environment so that the OpenStack client knows how to interact with your OpenStack services. So you have two options here for configuring your environment as you get two files. So using OpenStack RC file, basically this file contains the necessary credentials and environmental variables. So to authenticate with OpenStack to configure your environment, you simply source the OpenRC file by running source openrc.sh. So in case if you are using clouds.yaml file, which is located under this location, so .config OpenStack clouds.yaml, you can also set up your environment using this file. So once your environment is set up, you can basically begin running commands. So with the OpenStack RC file, you can run OpenStack server list. With the clouds.yaml file, you would use this command OpenStack --os -cloud OpenStack server list. Basically, both of these commands will give you the list of the servers in your OpenStack environment, but the key difference is in how the environment is configured. So either method works. So you can choose whatever the one that best suits your workflow. And moving on, so we will talk about importing SSH keys in OpenStack. So which is very important step for securely connecting to virtual machines. SSH keys basically allows you to authenticate without using passwords, making it more secure and efficient when managing the VMs. So to create and import an SSH key, you have two options here based on how your environment is configured. If you have used OpenStack RC file, you can run the following command to create a key pair. So basically OpenStack key pair create the public key and then the path of the public key and then the key name. So you have to simply replace your path to the public key with your actual path to your public key file and the key name with the name you want to assign to your key pair. And if you're using clouds.yaml file, the command is slightly different. So basically, you have to include OpenStack --os cloud OpenStack key pair create, your public key and path to the public key, and then the key name. So again, please replace the paths and the key names as needed. So once the key is created, you will be able to use it for SSH connections to your virtual machines within OpenStack. So basically, this setup is essential for managing your VM securely and conveniently. And uh, moving on to the next slide. So let's take a look at the VM images and default users in OpenStack. So first, for the latest supported VM images, you can find all the VM images listed within the Confluence page, EWC virtual images available. And so you can also easily retrieve the list of the available images by running this following OpenStack CLI command, OpenStack image list. So this will display all the images that are currently available for you to use when provisioning a new virtual machine. So now when it comes to connecting to your newly created VMs, OpenStack assigns default users for each image. The configured SSH public key is uploaded under this default users, allowing you to securely connect to the VM on your first login. So for Rocky Linux, as you can see from the table, it is cloud user, the default user, and for Ubuntu, it's Ubuntu as a default user. So it's important to know that which default user to use for each image. So the table in the slide, you can see it shows the corresponding default users for various images, which help you to ensure you're using the correct credentials for your SSH access. So yeah, that's about it. I hope this overview has been helpful in getting you familiar with OpenStack and its various tools and services. So now I would like to hand it over to Roberto, who will continue from here.
Okay, thank you, Rosa. So indeed, let's now demonstrate a bit what Uroosa showed in her slides. And we will do that through a quick demo about how to create new virtual machines using the Openstack command line interface. So for that, we'll start just listing some prerequisites. So first of all, we will need an Openstack command line environment already set up. So either a Python environment, but in any case, the Openstack command line installed, and also the availability of the Openstack application credentials. And beside of that, before, let's say, starting a new virtual machine, a new server, we need to collect some preliminary information, this at least a minimum required that to create our new virtual machine. So first of all, we'll need a key pair that Uroosa also show how to upload to Openstack. An image that will be the source for our virtual machines, so it will be either Rocky Linux or Ubuntu. Flavor, which is basically the configuration of resources, CPU, RAM, and disk that we will need for our virtual machine. Similar, this is the equivalent of the plans that you can see in Morpheus. And then which network will be attached to the virtual machine, typically the private network. And then also the security group, which is, I remind you, is a set of IP filter routes that define the traffic ingress and egress for your server. So we will collect during the demo all this information via the Openstack dedicated command. And so that I can show you also how to retrieve via command line interface this information. But of course, it's possible then later on also to script all of it. So once we collected this information, we're ready to go with the Openstack server create command, just passing this minimum required information via argument, and then also providing a name to our new server. After that, we'll be able to list and retrieve information about the created virtual machines. So if we attach the virtual machine just to the private network, it needs either a gateway or a floating IP that is a public IP that is assigned to the virtual machine that allows SSH access, or at least to access the VM from external. And this floating IP can be assigned via the Openstack floating IP create command. To create this floating IP, we need to pass as argument the external network that provides the public IPs. And once we create this floating IP, we can attach it to the newly created server via the Openstack server add floating IP command, passing as argument the virtual machine name and created floating IP. We can, in Openstack in general, command line client, it's possible to work either with names or to the ID. So we can specify in this latest command either the names or also the IDs, as we are going to show you soon. So with that, we start with this demo. I'll show you in this folder, I collected my Openstack application credentials with the OpenRC files and also the Cloud YAML that I will be using the OpenRC file, and also a set of key pair and the virtual environment. So now sourcing the Python virtual environment where I preliminarily installed the Openstack client, and then I will be also sourcing the OpenRC file to export the needed variable. Then I can show you also how to upload my public key to Openstack, as Uroosa showing at slides. And you can see that the key pair create command created my public key on Openstack, and I can also list it, Openstack key pair list. So this is at least set, and I can continue, let's say, retrieving the needed information that I mentioned earlier. First of all, let's have a look again at the help of the server command. I will need focus on the server create, but as you can see, there are several options for managing all your virtual machine, your servers. And then I can also retrieve the help of the particular server create command. And in this case, there are several options, but the minimum required that we mentioned are flavor, image, network security group key name, and finally we'll need to assign a virtual machine name. So with this, let's get started with collecting some information that are needed. Start with the image. I will do OpenStack image list, will show me the available images on my project that are include Rocky Linux and Ubuntu. For this demo, I'll be using mainly Rocky Linux, so let's grab just the Rocky one. And you can see there are several versions. I will get and copy the latest one. And you can see there is also the GPU one available in case you need to deploy that one. So take note of that, and let's continue also browsing the other information like OpenStack flavor list. Show me available plans and flavor within this project. I will take note of low spec one, which should CPU 2 gig of memory and 30 gig of disk. As mentioned earlier, you can see there is a column also for the ID, where you can use the name or the ID equivalently. And now let's see the network list. I can show you here also how to fetch just a value of a specific column, customizing the output of the list command, -f value, -c name. So c name is the column, and I will take note of the private network. So with this, I will continue also getting the latest information about the security group. So OpenStack security group list. And these are the three main ones that we provide within Cloud Tenancy. For this demo, I will just take the SSH one that allows me to get access to the created virtual machine. So with that, I can now I have all the information to run OpenStack server create, and I will pass the collected arguments to my command. So as I said, I'm using the name because it's easier, but you can use also the IDs for flavor image equivalently. So finishing also with the security group. And then I will assign a virtual machine, a name to my virtual machine, new EWC VM. You press OK, and then start the deployment of the virtual machine. This is the output of the command. You can see a lot of attributes and information, also including the one that I provided. And you can see that the status, as soon as I started, is in build. So it's building my new server. After a while, you should be able to check again the status via OpenStack server list. And you can see that the status turned to active, and also that a private IP was assigned to my virtual machines. However, I cannot connect directly via the private IP, so I will show you how to assign a floating IP. Let's have a look again at the help of the floating IP create command. It expects as argument network that provides the external network that provides the public IP. And now let's review again what are the networks available in my cloud environment. I will need to use, in this case, the external Ethernet one that will provide my public IP, my floating IP. So I will pass it as argument. And you can see that a floating IP now has been now created. So this is a public IP that I can attach to my server. So it's not yet available and attached to my server. I will need to do so by invoking the OpenStack server add floating IP. And then I will need to provide the virtual machine name or ID, and then the floating IP. So the output, the command, let's say, was run without errors. Let's have a look now about my server. So you can see now that also it's displayed the floating IP together with the private one. So I can, it's attached to my virtual machine. I can use that to connect to the newly created server. So as I showed earlier, I have a key pair, I will be using, let's say, the private one now to connect it to my server, or if you have an SSH agent is equivalent. And since I'm working with Rocky Linux, I need to use the cloud user. So I run and start the SSH connection. It asks me to add the new host to the known list of the host, and I'm inside. So now I connected. Cloud user and equivalently the Ubuntu user for the Ubuntu is able to impersonate and get root access, and then you can continue and customize that. So now let's move to Morpheus. So it's convenient to have the virtual machine displayed also under provisioning instances. However, I will going to show you how to get the virtual machine here, and also how to fix this health status that is not already shown, as well also the usage of CPU, memory, and storage. So to have the virtual machine there, you need to go under Infrastructure, Compute, and then under the virtual machines tab, you see the host that was provisioned via the Openstack API. So clicking, selecting the host, you can go to Action, Convert to Manage. And from here, you have this panel. You just need to select the no agent install. We are going to do that in a minute separately. And then press execute. I did it already for the one that I displayed. After that, I can show you how to fix the health status and also have the information of my instance about the usage of compute and of the resources. And this is done by installing the Morpheus agent in the VM. You can download the agent by going to the host, and then under Actions, there is this download agent script that you can download in your workstation. So let's have a look at the content of this script. I have this install agent, and you can see that is basically a bash script that downloads another script that is called invoked via bash. So I need to copy now this script on my target host if I want to install the Morpheus agent. And I will do that by simply calling the scp command and uploading it to my virtual machine. So I was able to transfer. So now let's connect it to the virtual machine. And I have it here. I will now just give it execution permission and invoking this script via sudo. Needs sudo access since it needs to download the needed packages and also install it on the system. And then it starts the installation of the agent and also the configuration. So after a while, should be able to finalize, and yeah, this is it was run correctly. Now you can go under the provisioning instances, and you can see that now the virtual machine is appeared here, and also that status turned to green. And also you can see the additional information about the usage of the resources that are sent by the agent. Under monitoring, indeed, the health status, it's everything green because in the monitoring and the checks are now successfully performed. And so with the VM and the agent installed present in Morpheus, you are now free to use it like the other VM provision by Morpheus, and also especially you can run workflow and task from Morpheus over the VM, like it was done if it was done on a normal created VM in Morpheus. So now let's have a look also another. I mentioned another thing about the server, which is about the DNS. So as you know, we provide this DNS service that automatically assigns the domain to your created virtual machine, and that is valid also in the case when the machine is created via Openstack API. So it follows the usual convention about virtual machine name, tenancy name, then F at ECMWF or S, and then ewcloud.host. And this, you can see that indeed the VM was resolved correctly, and I can use this domain to connect to my VM instead of the IP, for instance. And this is that's about it. So now let's have a look just another command that might be useful. So let's show how it's possible to reboot a command, but there are, as I showed earlier, there are several others commands available for the OpenStack server. Now let's show how to reboot it, and that is done via OpenStack server reboot, and then you pass either the VM name or the ID. And then you can see that after running the command, I can check again the status, and indeed it's in reboot. After a while, the VM should have been rebooted and available again, so it turned to active. So I may try now to reconnect again just to check the uptime. So I can check the uptime now. You can see that it was restarted less than a minute before. So the reboot command was successfully. So with this, I concluded the demonstration. And also we are at the end of the webinar, so I would like to point you again to the various contacts and references that we provide, so the main websites. Feel free to reach out via the discussion platform or the support portal for any need, or to consult our knowledge-based documentation. So, and with this, thank you very much. We can open the floor to questions, if you have any.
Yes, I actually have two questions. The first one is about setting up the the key pair, and just to see if I've understood it correctly. So you have to create the key pair by yourself with before using the OpenStack command, just like the standard tools, create private public key.
Yes.
And then the OpenStack part that you showed is basically only to upload the public key, and make it available to OpenStack. The private key remains, of course.
Exactly. So okay. Yes, I confirm that this is equal to the case when you work with the Morpheusly created VM. So you need first to have a pair of private and public key that you can generate via SSH keygen or whatever other tool. Once you have them, you can upload the public key to OpenStack via the command that we just show. This public key is injected under the default user, so cloud user for the Rocky Linux or Ubuntu user for the Ubuntu ones. And you can connect to the created server via that key pairs. So it's only by default it's only allowed the key authentication. So we don't support, as you may know, the password authentication. So
yes, makes a lot of sense. Okay, now I've understood it. The second question is about this whole workflow of converting the VM to a managed machine and then install the agent. Is that because I'm just asking because these are manual steps, are they really necessary? Because usually you would like to automate everything.
Exactly. So and just we have just demonstrated in the case that you want to have and manage the VM also in the Morpheus interface, but you can keep working just on OpenStack and avoid this step. So we have shown just to complement because perhaps some users want to manage this VM and also make them visible in Morpheus as well. But if you want to work just with OpenStack APIs and programmatically, there is no need for that.
Okay, thank you very much. That confirms what I had expected. And thank you also for the nice presentation.
Thank you. Probably I didn't mention earlier, but depending on your interest and also feedback, we may plan additional training sessions also exploiting this subject. Today we just show, since it was the first session, and the basic information how to use the command line client. But as we've mentioned, there are several other options for exploiting these Openstack API access. So yeah, I see a question about the video. These, like the others, will be uploaded. The recording will be uploaded in the event page, and also we will put the link in our knowledge base documentation. So about the when, perhaps Julia can say, but typically just that takes short time. I cannot say. So if you have, I see two questions to answer raised. Søren again.
Yeah, just one more
Okay.
quick question that I came up with. So is that OpenStack API available also from like outside ECMWF? So can I connect from like, for example, our internal CI/CD pipelines to use it and set up servers? Or is it restricted to, I don't know, IP ranges, nothing?
No, it's available and open also from external network. Actually, the demo that we have been shown, it was done from a network that is not inside the Open Weather Cloud. So I confirm that you can use this from other networks as well. And there is it exploits HTTPS connection, and there is no with the normal ports, so it's not restricted.
Thank you.
Now, Giuseppe.
Hi, thank you for your presentation. Is the only thing to require this application credentials by raising a support ticket?
Yes.
Okay. Do you see any security implication in sharing application credentials, key and secret key inside the ticket if the two files mentioned are shared via ticket?
So we didn't mention how we provide it to you, but we don't. That's not the case. So we don't provide the secret and the ID via ticket.
Okay,
so
thank
because
you.
Indeed so it's a bit more secured.
Okay, and the security, the application credentials are static, or I mean, do they have any lifetime?
So for the one that we're provisioning now, we are not setting an expiration time. However, if you have any reason, like a person that is leaving an organization, or if you have the feeling that they got compromised, we invite you to contact us so that we can erase or update them. But yeah, by default, there is no expiration time.
Okay, thank you.
Pierre?
Use the microphone. So thank you as well for the presentation. So a previous seminar was on using Ansible, for instance, for deployment of Jupyter. This one is on OpenStack. Is it possible to use the type of techniques we have seen in the Ansible webinar using OpenStack to automate it a bit further?
So what would you like? So because Ansible, as I mentioned, has some modules to interact with the OpenStack APIs. So, but typically, as we have seen from the users that work with these kind of tools, they deploy the infrastructure, so the virtual machines using other tools, and then they use Ansible to customize the provision of the instance. So it's a combination of, for instance, Terraform and Ansible. Even if Ansible has some capabilities, also some modules to talk directly to OpenStack itself. But yeah, in general, so since you confirm the interest, we might be planning another session using also this kind of tools to support, let's say, these automation capabilities that are enabled by this OpenStack API feature.
Okay, thank you.
Okay, is it possible to share OpenStack access within a tenant? So for that, we discourage. So we, even if perhaps you have some, so depending on your need, so you can request, let's say, the access, and we will keep track of the request that will be responsible for that API access. However, it's also responsible in case it shares with other people and users, or there is some common pipeline that make use of them. So but if let's say it's just a sharing with another user that makes an independent usage of these APIs, we just invite you to open a request for two separated credentials so that we keep track on who is using what. So yeah, you can share but you remain responsible for other people may do with your credentials. So we invite you, if possible, to avoid this not required. Okay, I don't see other questions so far, and also we have been reaching the end of this 1 hour webinar. So thank you very much for your attendance, and hope to receive your request either to get access to EWC if you are not yet a user, or to the OpenStack credentials. And please provide also feedback, any feedback that you may have. So thank you again, and see you in the next webinars.